Thank you, everybody. It's my honor to give this talk in the next 45 minutes. I have some slides. I don't know how quickly I will run through it, but my intention is introduce Amazon Cloud and more from data scientist perspective. It's not a typical type of machine learning talk. But it's kind of unique for people who don't have experience understanding cloud technologies. And I hope that you will learn something from this talk. Let me see if I can move my slide a bit. Okay, here's my agenda. 1 second. Yeah, I'll use my mouse. So I first have some introduction on Amazon Cloud. Then I will talk about some foundation services on Amazon Cloud. Normally, as a data scientist, you really don't need to know that. But once you get into a large type of production environment, you're going to have the discussion on these type of things. Then I will touch on very quickly on some analytics and machine learning portfolio, because there are many products and services, but I'll highlight a few important ones. If you happen to have a conversation with someone working on cloud technology, regardless is Amazon, Google, or Microsoft, they all basically the same thing. I used to work for IBM. It's all around the same type of technology stack. Some of them open source, and some of the enterprise solutions. I'll go into details over once we get to that part. Over time, my experience is building machine learning as a data scientist. Building a machine learning product as a data scientist need to deal with the workflow of the life cycle of machine learning and AI systems, and the core part of it is actually an environment you can integrate multiple pieces together, and that's your central part of the collaboration environment. And when I was working in IBM, they have a product, and I know Google has a couple products, try to do the same as Amazon, but SageMaker is a product I want to give some deep diving. Then I'll close with a little bit on how the current trend in data and AI, not just from cloud perspective, but on the broader sense, cloud is everything. Means a hybrid cloud, a multi-cloud, on-prem. So I will share some my personal view. It's not just totally my personal, but I read and talk to people. But that's looks like the current state. I'll share briefly on that. So over the years, the biggest tech companies such as Airbnb, Uber, Slack, they have built their business from scratch, and most of them on AWS, Amazon Cloud, because Amazon was the early pioneer in the space. In recent years, yes, there are Azure and Google and other players, even some in China, from China, like Ali Cloud and Tencent Cloud. But today, thousands of business enterprise of all size in every industry are using AWS to drive meaningful outcomes for their business and their customers. So from financial industry, you have Goldman Sachs, Capital One, Barclays, HBC. Almost all the companies, large and small, they use some of Amazon Cloud. It's just the size of the deployment, the maturity level. In healthcare, we have Johnson & Johnson, Merck, Pfizer, BMS, Novartis. In manufacture, we have GE, we have Siemens, we have Philips. In oil, we have Shell, we have BP. In media, we have Netflix, have Disney, have Fox, HBO. In travel, we have Expedia, Singapore Airline, Korea Airline, Hilton. In public sector, interestingly enough, I was working in public sector while I was in IBM. That's government. So in government, there's 6,500 government agencies worldwide currently using AWS. There are 9,000 academic institutions and tens of thousands of nonprofit using Amazon Cloud to power their business. So what exactly is Amazon Cloud? Amazon Cloud really means Amazon Web Services. Amazon has another large business called retail. That's the website you buy a product. Currently, Amazon retail is bigger than Amazon Web Services, but there's some, I mean, even the CEO of Amazon, Jeff Bezos, they predict in the future, Amazon Web Services will exceed the retail business, become the #1 business within Amazon. So if you look at this one, the takeaway you can have is just understand, there's an infrastructure at the bottom. There's a data centers built on region and availability zone with acceleration for content distribution. A foundation service is about getting the virtual machine and computing resources with a scaling capability and load balancing. On storage, we have different storage types, which I'll touch a little more. There's also security access control, and there's networking. So these are the foundation services. Today, I'll touch some of it, not a whole lot. Then there's a platform services. Mainly is from data scientist perspective, you care a little bit on database and analytics, but really behind the scene, you need to touch everything else, because there's a different type of application services support this database and analytics. There's deployment management component under the hood. At the end of the day, people using an application, whether it's web app or mobile app, but it's an application shared based on different type of vehicles. Say nowadays in COVID-19, we see a lot of people using web conferencing, but also there's a lot of people use remote workspace. Like Google have a G Suite, but Amazon also has a very large deployment for workspace, remote computer, just like you have a computer hosted in Amazon data center or cloud. From infrastructure perspective, Amazon had the largest, widest distribution in terms of geographical coverage. And then there's something called a region. Region is, if you look at this chart, US East, is a region. And in US East, we have North Virginia and Ohio. North Virginia actually consists of 6 data centers. They're a few miles away, fully redundant. If one data center failed, the other 5 will pick up the traffic or load. And not all the data center had 6 available, we call 6 availability zone, but some of them 3, some of them had 2. If you look at China, Beijing had 2, Ningxia had 3. They're really designed for many considerations. Sometimes it's compliance and security, sometimes it's regulation, data privacy, sometimes it's just an economical reason for, I get a good network traffic backbone, and sometimes it's because my electricity cost, energy cost is low in that region. But we're constantly expanding this all over the world. And this is This is a global infrastructure. So let's move into some foundation services. I'll cover something called Amazon EC2. Amazon EC2 is really some of the virtual machines equivalent. You have a Windows machine or Linux machine. We don't have a Mac on the cloud, but basically you can do Linux and Windows. Hardware-wide, the latest development in ARMs and different type of x86 architecture, that's very, very interesting. You're going to see a lot of deployment in this space because the performance and cost, energy saving, many, many reasons. And that make another justification to move to cloud, because if you buy hardware, your hardware will be outdated in 3 to 4 years. And in Amazon Cloud, you can do like a click and go for upgrade. There are different type of EC tools. I don't know the number, hundreds, maybe 100 to 200 different type of EC tools. So we have the widest, most numbers, largest numbers of instance types compared to other cloud vendors. And you can also build customized AMI, so customized images. In on-premise system, you build different server and desktop hardware and software operating system. There's many, many customizations because we have a largest ecosystem from partners and vendors. If there's something you want to learn EC2, when you have a conversation on Amazon Cloud EC2 Compute, and that's basically 3 things you need to look at it. There's something called a C5N. So it's the kind of an instance, it's a C type of instance. Then you have an attribute of phi-n is the generation. And then you have X large is kind of the type. This is what it really means. So we have different type of compute system. Just like you run any database or data warehouse system, underneath you need EC2. So there are different type of workload. There are general purpose workload for burst stable performance or general purpose, that's T and M. You will have some compute optimized just for compute intensive operations, that's the C and C types. Then you have memory, R, X, Z. You have a G for accelerated computing. If you look at the P is GPU and the F is FPGA. And you have storage optimized, mainly for some database and the dense storage, big data optimization types. So without these types, no matter database software you run, you are going to suffer performance opportunities. So with this vast portfolio of instance types, it gives us a lot of options to choose to build a better computing resource, or what we usually call the fleet. It's a large number of pools of servers in thousands. And at the bottom, you see ARM systems. We're constantly working with vendors to build custom optimized EC2 types. And that is very fascinating and exciting. For storage, there's 3 types storage called a block, file, and object. I'll just use the next slide to let you know that there are different options to use storage. If you deal with machine learning, you rely on data. You rely upon a vast amount of data, hopefully, and in real time, maybe in a distributed manner across the country or across the region or worldwide. For example, if you deliver some media services, or if you deliver, say, Airbnb, if you deliver something particularly like Lyft and what did the other call? The other company, yeah, Uber, right? So you need that data constantly feeding into your system, and you need a different type of performance, but also with reasonable cost. And with good reliability, you don't want to lose data. So this product probably is industry-wide the most matured portfolio in terms of cost. You have lots of choice in object storage. In terms of performance, you have a lot of block storage, and also there's a good balance in terms of different type of location, distribution, performance. We have different type of file storage. At the end of the day, you need a backup system, and we also have a very low cost, high performance backup system for you. I won't go into too much deep coverage in database, but I want to just bring your attention to Amazon Aurora is a database product enterprise ready for MySQL and PostgreSQL. And it's much better in terms of performance with lower cost. And it offers industry enterprise-grade performance, scalability, availability, and the security. Most importantly, it's easy to manage because you don't need to manage the hardware operating system. Amazon doing that for you. If you have been into cloud space, you must have heard of the story of Redshift. That is probably, beside the EC2 and S3, the next leading product to change the analytics industry. It provides a terabyte scale of massive parallel column store relational data warehouse, fully managed, no admin, with the cost as low as $900 per terabyte per year. Many large companies move to Amazon Cloud because two things. One is S3, one is Redshift. S3 provides a large scalability, cross-world, low-cost, highly reliable storage. It's very good for small business, large, actually also for a lot of startups, but also for very large company nowadays, widely being used. But the second one is Redshift, because when your company find you have performance issues with your data warehouse, you can quickly use Redshift to understand what is possible. And it's a matter of you take your credit card and pay that maybe a few $100s and see it immediately. Database, there's a type of non-SQL database. Amazon DynamoDB is a product covered non-SQL space. If you see web application development, many people do not use relational database for performance reasons. They use non-SQL. So DynamoDB is a product for that. So I think I will conclude my foundational service with this slide, because at the end of the day, you are data scientist. You want to use this many service for something. Primarily, I think it is because you want to do some ETL and data integration. And Amazon had Glue and other services to help you to manage ETL and the data integration, data governance, data catalog challenges. I won't go through the details, but these are there's a chart here to tell you how to put everything together. There's a vast, you cannot see anywhere else to see the design patterns. This is all public on the Amazon website. Thousands of those. So then we'll talk about the analytics solution. I covered a little bit in the previous slide, but I'll try to emphasize this thing differently. Amazon EMR stands for Elastic MapReduce. It's a product. Early days when we have Hadoop, that is how they've been named. But over time, they have a Spark, they have a Presto, all the other open source software portfolio under this offering. You get the latest version because upgraded software is just taking effort. Spark coming with 3.0 lately, and if you have a team to put the Spark into an upgrade, that's a good effort, right? I used to work for open source software. Those people are charged $500,000 early days. No company can pay for that nowadays. So definitely it's cheaper, easier nowadays. So when we deal with big data, a particular type of data is called real-time data. So Amazon Kinesis is a solution for you to collect, process, analyze data, both from structured or unstructured data types. Can deal with semi-structured data, text, and also video, images. There are other services like a Kafka. Managed Kafka service is also a product offered on Amazon. I just try to bring some early key product. If you have a customized solution requirement, you usually want to get into the conversation with our solution architect. We'll host a meeting with you to understand whether you need a different type of solution, and usually you do. For analytics, just like the way I talk about conventional foundational services, it's not just one service. Usually it's multiple services, you chain them together. And Athena is our Presto query engine. And S3 is our storage. And most people keep data lake on S3 because they're cheap and distributed and easy to be accessed by ETL and catalog engines. You can use Glue and you can use something else. You can build something on top of EC2 and you can do this even outside Amazon cloud, on-prem or even other cloud, but it's fully scalable. So we have covered foundational services, we covered analytics and big data, but you come here to learn big data, machine learning, and AI. So you need to go to the top, right? So that is machine learning and AI. It can be overwhelming for people to understand what is the offering from Amazon for ML stack. It's broadest, deepest set of capabilities because we've been there long, have a large number of customers. We know their requirement. They ask us and we deliver. So these are the products we have. We'll look at it. Again, I ask you to look at the bottom. On the left side, bottom left side is called ML frameworks and the infrastructure. So two pieces. Framework, it's mostly dominated by open source, particularly TensorFlow and PyTorch. And infrastructure, that's what I mentioned. There's a lot of exciting opportunities nowadays happening with AI chips and high performance computing. ARMs, REST. So all kinds of things exciting happening there to power the infrastructure. Of course, the framework side, like PyTorch and then TensorFlow are, fighting who is the #1 in the next few years. But in the middle is called a machine learning service. And when I was in IBM, I know why this is so important. So important for data scientists, because on the top you have AI services. They're good, they're important, they're useful, they're cutting edge. But for most people, you won't be able to, I wouldn't say wouldn't be, but a lot of emphasis, they're different. ML services try to build, train, deploy machine learning model. But AI service is really about consume this inside of application. But you can also consume the pre-built models from computer vision, video, or natural language. But most of the business, you want to build your custom model. You have a lot of data in-house. You have a website. You have an e-commerce. You constantly getting data or different data inside the organization, outside organization. You actually go through this cycle over again to prepare data, train the model, and deploy and test. So that is something at the end of this talk, I will maybe spend 15-20 minutes to talk about SageMaker. So that's this one, which I will pretty much cover. I will skip this now because I have another slide to cover it in details. If you want to learn Amazon Cloud, nowadays it's become challenging, even for people like me. I started with Amazon Cloud, then I work for open source, I work for IBM. Now I'm coming back to Amazon. I still feel like it's kind of, sometimes you feel you're a little late in the game because there's so much going on. But continue to be exciting if you understand why you want to do so. And there's certificates, and some have an adjustment now. On the left side, you have specialty, you have big data, and the machine learning. So I mean, if you're a data scientist and you want to extend a little bit, you can consider these two certificates. But security is the center of everything, what I believe. If you're really doing cloud, you learn security, almost touch about everything on cloud. So let me dive into this little bit on SageMaker. So what is SageMaker? So before I get to that topic, let's look at a Gartner. I mean, I learned this thing, Gartner report, Magic Quadrant report every year, like February, March, they publicize this and they rank all the vendors in terms of the product. There are different ones, their database, there's the cloud, their analytics, their BI. But for building cloud AI, this is the chart which published this year. I think they're not ranked very on the top. All the four company, AWS, Microsoft, Google, and IBM. I think it's because there's still lots of rooms to improve. But if you look at a data warehouse or even cloud, these people are straight on the top, or even BI. So I think there's this market is still evolving and being developed. So I think you're going to see even better tools the next 2-3 years. So today, there are tens of thousands customers using SageMaker. Why? Because they're already on Amazon Cloud. Why not? This is a very easy decision, right? So I'll share a couple stories also here, but literally, if you launch the product in such a bigger platform, it's just in the matter of a few months, you'll get 1,000 customers by nature, because they've been using your EC2 or Redshift or S3. So they talk to us all day long, and I'm an account manager. I've been talking to them like every day. Every day they have a requirement, and we are trying to find the best fit for them. If they talk about machine learning, we're going to recommend different things, but SageMaker is among the top of what we recommend. So we can talk about a couple customer deep diving. I haven't really looked deep into these cases, but I have a high level understanding. I didn't implement these solutions. These are the references we can open to public. I'm under agreement that I will not share something, proprietary. In fact, that's very important for us. It's a culture of Amazon. We don't talk about our competitors much. We focus on our customers. So that's something I learned here, and it's a pretty interesting, I say, company culture. So the problem for this is the self-driving cars for Lyft. There's a problem how to collect across different teams for develop machine learning. And I believe that they all very techy environment, engineering focused. They're geeks and engineers, software developers, data scientists, and machine learning engineers, and they know what they do. They build lots of systems. But they have a problem to integrate them. How do you collaborate with them? Standardized on Amazon SageMaker for training and build and deploy is a natural step. I mean, they may still keep some of the system running independently, but they could always find a backfill to use Amazon SageMaker to solve their issue, to build a machine learning model and have machine learning pipelines. And the important thing is reduce engineering cost. It's good and bad, right? We work hard to get rid of our jobs. So second use case is is about lots of streaming data, RFID tags, because these players had these tags on their body and when they play games, and that streaming to collect a large amount of data in terms of terabytes or petabytes, daily, weekly, yearly, season-wide. So this, again, is a good problem to have, and it's an easy problem to solve using SageMaker, because it's not just SageMaker. For storage, for streaming, for preparing, for warehouse, for query engine, for security, for distribution, and everything, right? Even for content acceleration, right? Yeah, use case more about compliance. In the financial, healthcare, and several industries, they have a great challenges to meeting compliance requirement. Everything you do, you want to understand how you do it, why you do it, what if you don't do it. So without the key security and manageability, you are not going to scale this up. And we can use Amazon Cloud with SageMaker to build at scale and meeting compliance and internal security requirement. So that is I think that's this use case. I have some architecture diagrams and technical details. I think that's not the point for this talk. The talk is understand from business perspective this use case, why they're there, and how you can replicate these use cases in your own organization. So I'm 30 minutes mark. I think I'm a little bit ahead of my schedule, but that's fine. So when I was talk about machine learning platform, I spent a long time to talk about it. I demo it, I show it, I tell them all the tricks and the features. I mean, you can spend like a week to learn this product, but you only have a few minutes with me, and I'll tell you quickly, right? So for one thing, you have a ground truth. Is basically data labeling. You see that a Gartner quorum, magic quadrant report, right? It's still not over the top corner. Why? Because this machine learning pipeline and process is complex and detailed. There's a lot of things you can do to help and improve. And of many of these use cases, sometimes they all differ in some way. So I think we're, as an industry, are still working very hard to make this easy. For example, data labeling, right? There's a lot of different type of data. They have 3D data. They have videos, image, and text. So build an application to label them. It's not a trivial task, right? And for processing, nowadays you all use Python, and you may use R, and you may want to say, okay, I have a system in-house, but I want to move to Amazon. So maybe we say, oh, bring your own license, so you don't need to repay. You get the, bring your own license cost. So this is something, several things you can do. I think it will be more. I mean, Amazon had an annual reInvent. This year is going to be in November, end of November and early December. Then there will be new product launched. Every year we have probably 700 services launched every year. So I'll be waiting to see what's happening here. Then this is prepared. Then you have build. Build with the first thing called the Studio Notebooks. I mean, this is probably nothing fancy or special. I mean, a few years ago, people think this is pretty exciting, but nowadays it's pretty common. But the uniqueness of this offer is we call the with elastic compute. Means you can scale this up and scale this down. I mean, when you run, say, hey, I do a project around Kaggle computation, then I run my GPU. I can do like 20 hours or something. Great, I'm done. But if you're running a production overnight by non-stop, you want to have elastic capability. It means you can go up and go down. Peak hours you go up, low hours you go down, right? And you don't want to do it yourself because system manage it for you. Amazon will scale this up and down. That's what we call the first thing called elastic compute engine, right? So elastic compute. Yeah. So remember I said the building algorithms. Building algorithms. What I mean building algorithms? There's algorithms you build and the algorithms other people build. But you want to bring your algorithm into SageMaker. How do you do that? Yeah, we can do it. Yeah, both supervised or unsupervised. Okay, you have algorithm, I have algorithm, but company also hundreds, thousands companies also build their algorithm. Where are they? You can find in Amazon Marketplace. They all preloaded, pre-built for you. Okay, if I want to build a ImageNet or something, healthcare or something, maybe somebody already built something for cancer detection or maybe commerce website. I want to see how do I detect the shoes and clothes. Someone probably built that for you already. At the end of the day, once you've done all the hard work, you just need to click the mouse, one click. They call autopilot. So the machine learning job in terms of in SageMaker is just like that engineering job get rid of the engineers lift. Here is get rid of a data scientist. Data scientists have no job to do because this SageMaker autopilot will do the job. So that's build. Deploy and manage on the left bottom corner. As I mentioned, that there are different type of deployment types. The first one is called elastic inferencing. You know what? Early days, I thought the training model is the biggest cost for running a machine learning system, but that's not right. In fact, most of the workload you see is inferencing. It's when you click the button on Amazon, you're looking for things. It's not training the model, it's running the model. How to do that in high performance and low cost? We have Inf1. If you want to know more, you can search online to find out, right? All these models cannot go by themselves. That autopilot is good. It just run, finish it. But will you be able to deploy? No. You need to have someone to review it and make sure that you don't lose business because you have a great data scientist. Yeah. So the key thing over here is just the one-click deployment, just like that autopilot. One click you can trim, but it's an iteration process, not that simple. But the one of the key unit of that operation is deployment, and it can be done real-time, batch, and multi-node mode. An important thing is you want to see the metrics, right? Metrics. You need to explain it. You need to understand it. You don't just blindly train and deploy it. That's why machine learning still require human to understand and manage. So actually, I take this a little bit backwards. This, prepare, build, then it's train, then deploy, right? Because I think I covered autopilot. Then there's a one-click train, one-click deploy, but also there's experiment and debugging. And that's when debugger is newer ones, and some of these are pretty new. And that's why I say this platform is still evolving. So I'll quickly run through, I'm 45 minutes now, so I'm going to quickly run through a couple slides, and hopefully I'll close this in 7-8 minutes. And this is so update the model in C impact. This is the UI called a studio.
Hi, Andrew. I just want to remind you we had 3 minutes left.
Oh, 3 minutes. Okay, I thought I have 7 minutes. Okay, I'll finish. Yeah, no, thank you. So this is autopilot. You can see there's so many processes running at what time start, what time they finish, what they deal with. These are the bring your own, this is pre-built, bring your own algorithms. This is the marketplace. You can see different companies had the audio NLP forecast as an experiment. You can run many times in different places, different where, and compare thousands. Yeah. You can debug it when you have issues. I mean, notebook. It's not like PyCharm or something. You can look at what's going on underneath. I can monitor. Yeah, I said inferencing is important, right? So there's a C and P and G inf1. So it's kind of a lot of choices. I have 2 more slides. Hopefully, I'll finish. So yeah, so inf1, yeah, beautiful ground up. So Amazon built this chip and the instance type, very cost effective. So I will close my talk by sharing some key development in the AI big data space. So the first thing is the third wave, from Hadoop to cloud service to Kubernetes plus Snowflake. If you don't know what I mean, that's okay. But you just know that cloud is not everything. It's a next generation of how to work with cloud. Then I focus on cloud topic today. So I want to bring you this concept of machine learning operation and the AI operation. Because this is if you interview Google job, they'll test you in this very much as an important category rather than algorithms. And so this exciting years for imaging video, and the last year or this year is NLP. So machine learning get deployed, embedded, I say the AI service, and also the training model and deploy model, right? Because when we talk about deployment, we talk about at end of it. We didn't focus on build about it. But when you deploy it, you can talk about you productionize it. And it's all happening every day, everywhere on Amazon Cloud. And we solve this issue that this Google paper, right? That the black box is 5% of the code. Rest of the code is everything else. And that's what Amazon Cloud for machine learning. Thank you. That's my talk.
Okay. Thank you, Andrew. Okay. And that's a good talk. So let's go to the questions. So let me see. We have a question from Isang On. Just one moment, IT service market is still smaller than the retail market. I think this is about the cloud market.
Okay.
Your points.
Okay. I can clarify what I really mean. I mean, I didn't say IT market is bigger than retail market. I say within Amazon, they foresee Amazon retail won't take over the world by big portion. Retail will be still there. Amazon may take 5%, 10% the tops. You have Alibaba, you have worldwide, right? But from cloud perspective, it's less competition, right? So that's what I really mean. But maybe I'm wrong. It's not on paper, so it's just my opinion or my interpretation of what Jeff Bezos said to us.
Okay. Another question is about, okay, it's a startup. Okay, as a startup company, we have scale problem in our engine, chat engine. Is there any solution for this? I think it's about a solution.
Okay.
Scalability, I think.
Yeah. So it's a sensible question. There are two things here, right? First, you build a chatbot. So how do you build that chatbot, right? Building that chatbot have different products and the services. Google Dialog, right? IBM had this Watson Assistant. In 1 second, in this chart, sorry, I'm not very used to this keyboard. I'm switching to this window machine last week. I could switch. One more, please. Okay. So when you say chat, there are many things. It can be voice, can be text, can be speech, right? And depends on what you say. So there's different services. What do you use for this service? These services, these services give you a framework. You can copy how Amazon building the AI solution as a chatbot. You can copy this framework in terms of the code, but the model wouldn't work for you because you have your business process, you have your business flow, you have your text, the nature of, say, customer service or maybe telephone service or security, help or IT service, whatever. So that type of data need to fit into SageMaker in the middle so that you can build that model. Sometimes you don't use it. There's other tools help you use it, and something in between AI service and the ML service. So that chat engine, you need to use a combination of both. In terms of a scale on that, it's a very big topic. So I don't think I have time to explain building how successfully we can build a chat engine. It takes a lot of work. Yeah, it takes a lot of work.
Okay, so the next question is how to do data cleaning in SageMaker. I think that's a very special.
Data cleaning, there are many things you can do, primarily in the Amazon SageMaker build stage. We have a data labeling, right? But labeling that including that, remove the data, do data normalization, do binning, do dealing with missing data, doing merge. But you can do also in a notebook, right? I say that training everything one click and it's not that simple, but that's still doable. Notebook, you can use pandas, you can use Spark. So that all you can help you to do cleaning. And we have glue, yeah.
Yeah. I think the last question, not the last question, okay. We are running out of the time, so we can only pick up. Okay, this is a quick one. Andrew, can you share your contact info? Can you go to a slide, the last page? I think you have the.
Yeah, so I guess let me escape
okay.
this.
So we have to be quick. We are running out of the time. So let me see. One question from Peter. So the question is, compared to retail price per TB, I think a terabit, the cost per TB as stated on the here rather high. I think.
Okay, I think you misunderstood. You misunderstood that $900. That $900 is not on the hard drive. It's a data warehouse software. Right. So that's Redshift per year, $930 something. Okay.
So yeah, thank you, Andrew, and thank you to give us a good presentation. So definitely, we are running out of the time.
Okay. Thank you for having us.
We have to go to our next speaker, and if our attendees, if you have any question, you can continue ask in the Q&A window, and Andrew may stay for another couple minutes to answer your questions through the text. Okay, let's go to our next speaker. Okay, thank you, Andrew.
Thank you for having